Hello students, last class I explained sequence definition with examples. Next, constant sequence and range of a sequence. In this class I want to explain about boundedness of a sequence. In this topic we have three more subtopics. They are bounded below sequence, bounded above sequence, bounded sequence. First, I am explaining here bounded below sequence. Bounded below sequence. So for this we need to consider one sequence first. So a sequence Sn is said to be bounded below sequence. When we say that this sequence is said to be bounded below sequence, if it satisfies some condition. What is that condition say here? If there exists any real number. I took here k1 belongs to R. So k1 is my real number. If there exists any real number such that k1 less than or equals to Sn, that real number should be less than or equals to each and every term in that sequence. So k1 less than or equals to Sn for n belongs to Z plus. Okay, this real number should be less than or equals to each and every term in this sequence. Then we say that that sequence is bounded below sequence. Next, the number k1 is said to be, the sequence is said to be bounded below sequence. Then the number k1 is said to be lower bound of the sequence. Okay. If it satisfies this condition, then we say that bounded below sequence. If it does not satisfy this condition, then we say that that sequence is unbounded below sequence. Okay. If it satisfies, we say that bounded below sequence and the number is said to be lower bound. If it does not happen, then we say that that sequence is unbounded below sequence. Okay, examples are, let sequence Sn be the set of positive integers. Positive integers are nothing but 1, 2, 3 and so on up to infinity. So therefore sequence Sn is equals to 1, 2, 3, 4 and so on up to infinity. So we need to find this type of condition. Any real number should be less than or equals to each and every term in that sequence. So I am considering here, is 1 less than or equals to 2, 1 less than or equals to 3, 1 less than or equals to 4, 1 less than or equals to 5. So 1 is the least one. 1 is the least one, right? So 1 is less than or equals to each and every term in that sequence. So we can say that 1 is a lower bound of the sequence. So therefore 1 is lower bound of the, 1 is a lower bound of this sequence. Okay, lower bound of this sequence. 1 is a lower bound of this sequence, but according to the real number system, there are -1 is the least one when compared to the 1, -2, -3. All these are comes under lower bounds only, right? So -1, -2, -3, all these are lower bounds. But 1 is the lower bound of this sequence. Okay. So we found lower bound. So we say that sequence Sn is bounded below sequence. Okay. This is our first example. Second example. Sometimes they may give nth term. From that we need to find a sequence. So in that we need to find lower bound of a sequence. If Sn is equals to -1 power n, for n is any positive integer. Okay, every time we need to consider n belongs to Z plus. Why? Because our mapping is sequence mapping. S from n to R or S from Z plus to R by the definition of a sequence. So we need to consider n belongs to either Z plus or n belongs to capital N. Okay. So here they give Sn is equals to -1 to the power of n. From this S1 is equals to Sn is equals to minus 1 power n. So S1 is equals to minus 1. S2 is equals to minus 1 whole square. So even positive sign. S3 is equals to minus 1. Again S4 is equals to plus 1. Therefore sequence Sn is equals to minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 and so on. If minus 1 to the power of 100, then positive sign. Why? Because if power is even number, we get positive sign. If power is odd, we get negative sign. Minus 1 to the power of 100 plus 1 minus 1 to the power of 99 plus 1. So either we get minus 1 or plus 1. Okay. Therefore, minus 1 is a lower bound. Minus 1 is lower bound, obviously. Minus 1 always less than or equals to plus 1. Negative sign always less than or equals to positive sign. So we can say that minus 1 is a lower bound of the sequence Sn. So we found lower bound. So we can say that sequence Sn is bounded below sequence. So these are the examples for bounded below sequence. Also there is an unbounded below sequence, right? For example, if Sn is equals to minus n, if Sn is equals to minus n for n belongs to Z plus, then we have sequence Sn is equals to minus n. If S1 value minus 1, minus 2, minus 3, minus 4 and so on, right? So minus 2 less than or equals to minus 1, minus 3 less than or equals to minus 2, minus 4 less than or equals to minus 3 and so on up to infinity. So there is no chance to find a lower bound. So this is a, so if we not found any lower bound, then we can say that the sequence is a unbounded below sequence. So sequence Sn is not a bounded below sequence. So if it is not bounded below, what we need to say? Otherwise the sequence is unbounded below sequence. So this is unbounded below sequence. Okay, clear? These are the examples for bounded below sequence. Next topic is bounded above sequence. Okay, next definition, bounded above sequence. See here, on comparing, this definition is same as before definition, but the only change is there we have K1 less than or equals to Sn. What we have here? Sn less than or equals to K2. So K2 is a greatest number, right? K2 is the greatest number. What we have here? K1 is the least number. So K1 is a least number. So we can consider K1 is a lower bound. What we have here? K2 is the greatest one. So we say that K2 is said to be upper bound of the sequence. Okay, see here, sequence is said to be bounded above sequence. Bounded above sequence. When we say that this sequence is bounded above sequence, if it satisfies this type of condition, there exists any real number K2 such that K2 is greater than each and every term in this sequence. So that is nothing but Sn less than or equals to K2 for n belongs to Z plus. Then the number is said to be upper bound of the sequence. Okay. If it satisfies, the sequence is bounded below. If it does not satisfy, the sequence is unbounded above sequence. Okay. What is the example here? I am considering here, if Sn is equals to 1 by n for n belongs to Z plus, then we can find sequence. Put n is equals to 1, 1 by 1, n is equals to 1 by 2, up to infinity, positive integers, 1 by infinity. 1, 1 by 2, 1 by infinity is nothing but 0. 1 by infinity, 0. Here we need to find greatest term. Greatest term, and that term should be real number. Is 1 is greater than 1 by 2? 1 is always greater than 1 by 2. 1 is greater than 0. Next 1 is greater than 1 by 3. 1 is greater than 1 by 4. So 1 is a greater than to each and every number in this sequence. So we can say that 1 Sn less than or equals to 1 for all n belongs to Z plus. Therefore, sequence Sn is bounded. What we found here? Greatest number. So this sequence is said to be bounded above sequence. If we found bounded above sequence, so there we can find upper bound. So 1 is a upper bound. Upper bound of sequence Sn. This is the example for bounded above sequence. So we need to check unbounded above sequence also, right? I am considering same example what I am considered in last definition. The sequence Sn is set of positive integers. Then sequence Sn is equals to 1, 2, 3, 4 and so on. So there is no chance to find greatest number. Therefore, sequence Sn is unbounded above sequence. Okay, these are the examples for bounded above sequence, unbounded above sequence. Next, bounded sequence. Next definition, bounded sequence. A sequence is said to be bounded sequence when we say that the sequence is bounded sequence if it satisfies one type of condition. What is that condition here? If its range is both bounded below as well as bounded above sequence. If its range is both bounded below and bounded above, then we say that that sequence is bounded sequence. Range is nothing but the set of all terms of a sequence is said to be range. Okay, if it satisfies these two conditions, then we can say that that is bounded sequence. If it does not satisfy any one of these conditions, then we can say that that sequence is unbounded sequence. For example, if Sn is equals to 1 by n for n belongs to Z plus. This is our nth term. From this we can find sequence, right? Sequence Sn is equals to 1, 1 by 2 and so on 1 by infinity. 1 by infinity value is nothing but 0. See here. What is the range of this sequence? Range of sequence Sn is 1, 1 by 2 and so on 0. Range is nothing but the set of all terms of the sequence is said to be range of a sequence. This is our range of this sequence. Here 0 is the least among all those terms in this sequence. So 0 is the lower bound of sequence Sn. Next, and 1 is the greatest one among all those terms in the sequence. So we can write 1 is the upper bound of the sequence. Now we find least one as well as greatest one. So we can write the sequence is bounded below sequence and sequence is bounded above sequence. Therefore, sequence Sn is both bounded below and bounded above sequence. What is the definition of a bounded sequence? If it satisfies both bounded below sequence and bounded above sequence condition, then we can say that that sequence is bounded sequence. So we can write here sequence Sn is bounded sequence. This is an example for bounded sequence. We need to check unbounded sequence example also, right? So, for example, if our nth term Sn is equals to n into minus 1 to the power of n, for n belongs to z plus, that is nothing but n is any positive integer. Put n is equals to 1. Then sequence Sn is equals to, put n is equals to 1. 1 minus 1 to the power of 1 minus 1. N is equals to 2. Then we get positive sign, minus 1 square. Okay, 2 next, minus 3, 4, minus 5 and so on. Here there is no chance to find the lower bound as well as upper bound. Why? Because on comparing negative sign, see here, minus 3 is less than minus 1. Minus 5 is less than minus 3 and so on. Similarly, 2 less than 4, 4 less than 6, 6 less than up to infinity. So there is no chance to find upper bound as well as lower bound. So this sequence is not bounded above and bounded below sequence. This is not bounded above as well as bounded below. So we can write sequence Sn is unbounded sequence. This is the example for unbounded sequence. Here we have two more definitions. Least, greatest lower bound, least upper bound. These two definitions are based on these topics only. Least definition, greatest lower bound. This is also known as infimum of a sequence Sn. Greatest lower bound of a sequence Sn. So for this we need to consider a sequence first. So let sequence Sn be a sequence of real numbers, and the real number S belongs to R is said to be infimum of sequence Sn. When we say that this is infimum, if it satisfies two conditions. First of all, it should be lower bound of sequence Sn. Why? Because what is our definition name? Greatest lower bound. So for this, first of all, it should be the lower bound of the sequence Sn. Next, second condition, if sequence Sn has lower bound other than S. Why we considered another lower bound? Why? Because if we want to say S is the greatest one, we need to consider one more lower bound, right? So I am considering here second condition is sequence Sn has lower bound other than S. That is L belongs to R. Then L less than, it should satisfy this type of condition, L less than or equals to S. See here, L is a lower bound, S is also a lower bound. Which is the greatest one? S is the greatest one. So we can say that S is the greatest lower bound or infimum of sequence Sn. See here example, if sequence Sn is equals to 1 by n, set of 1 by n such that n belongs to n. So the set is nothing but, put n is equals to 1, 1 by 1, 1 by 2, 1 by 3 and so on, 1 by infinity. 1 by infinity is 0. Clearly 0 is real number, so 0 belongs to R. First condition, 0 belongs to R, S belongs to R, so 0 belongs to R. Next step, to say S is an infimum, it should satisfy two conditions. Now I want to say 0 is the infimum of this sequence. So first of all, it should satisfy these two conditions. See here, S is the lower bound of the sequence. From this sequence, our 0 is lower bound of the sequence. Yes, 0 is the lower bound of the sequence Sn. See here, on comparing, we know that minus 1, minus 2, minus 3 and so on are lower bounds of sequence Sn. All these are lower bounds of sequence Sn. If 0 is lower bound, then minus 1 is also a lower bound. Minus 2 is also a lower bound of the sequence. Minus 1 is also a least one among all these terms of the sequence. Minus 2 is also a least one among all these terms of the sequence. Next, see here, minus 1 less than or equals to 0, minus 1 less than 0. minus 2 less than 0, minus 3 less than 0, and so on up to infinity. So 0 is the greatest one. Minus 1 lower bound, 0 is also lower bound, but 0 is the greatest one. Similarly, minus 2 lower bound, 0 is also a lower bound, 0 is the greatest one. So this condition satisfies each and every term of the sequence. So therefore 0 is the greatest lower bound of sequence Sn. So greatest lower bound is nothing but infimum. So infimum of sequence Sn is equals to 0. This is an example for greatest lower bound. Definition: least upper bound. This is also known as supremum of sequence Sn. First of all, we need to consider sequence Sn be a sequence of real number, and the real number is said to be supremum. When we say that this is supremum, if it satisfies two conditions. What are the conditions? First of all, it should be upper bound. Next, S is a upper bound of a sequence Sn. Next condition is sequence Sn has upper bound other than S. I am considering here another upper bound is L belongs to R. Why we consider another upper bound? Why? Because what is our definition name? Least upper bound. Already we have one upper bound. To say this is the least one, we need to consider another upper bound, right? So I am considering here another upper bound is L belongs to R. Then it should satisfy one condition, S less than or equals to L. Next, see here example. If sequence Sn is equals to 1 by n, same example. What is our upper bound here? 1 is the upper bound of sequence Sn. Is 1 is real number? Yes, 1 is real number. So 1 belongs to R. First condition, 1 is the upper bound of sequence Sn. Here S is the upper bound of the sequence Sn. In place of S, what we have here? 1. So 1 is the upper bound of sequence Sn. Next, also we have 1 is the upper bound of the sequence Sn. 2 is the upper bound. 2, 3, 4, 5 and so on up to infinity. All these are upper bounds of this sequence. Are upper bounds of sequence Sn. On comparing, 1 is the least one. 1 always less than or equals to t. 2, 1 less than 2, 1 less than 3, 1 less than 4. So 1 less than or equals to each and every term. So therefore 1 is the least. 1 is the least upper bound of sequence Sn. So therefore we can write supremum of sequence Sn is 1. This is the definition for least upper bound. Okay, see here. These are the topics we discussed till now. Lower bound of a sequence, nothing but bounded below. Next, greatest lower bound of a sequence based on this definition. Similarly, upper bound of a sequence. Next, least upper bound of a sequence. This is based on the definition of upper bound of a sequence. Next, bounded sequence definition. These topics we discussed. In my next class, we will discuss about a convergent sequence, limit of a sequence, next uniqueness theorem. Thank you. Please share and subscribe my channel.